Welcome to this technical corner. I'm with Barry Rooney from Prima Power. Barry, today we're talking about bending technology and the machinery that you offer. Tell us what the options are.
Okay, so we've basically got three different options. We do press brake technology and panel bending technology, and within the press brakes we've got servo electric machines and hydraulic machines.
Okay, now let's start maybe with the press brakes.
Okay, so with the press brakes we have, as I said, two different product ranges. The servo electric machines generally are general purpose machines, and as you can see there, we can do those with a high level of automation as well. They are very, very high reliability machines, very, very accurate because they're using servo electric technology instead of hydraulics. On the hydraulic side of things, the reason we have those are for larger, high demand applications where we are processing thicker materials, for example in the yellow goods industry, which is why we have the two complementary technologies.
Would it be fair to say though that electric is a much more popular seller for yourselves?
For us, yes, because the electric technology fits perfectly with all of our other product ranges as well. What our customers generally are looking for from us is very, very high levels of accuracy, reliability, consistent performance, which is what you get from a servo electric machine.
And with the press brake, there can be a lot of, I know we saw the automated one there, but in general terms you could have someone feed in the machine, wouldn't you? Which can create bottlenecks, I suppose, and it's not as efficient as maybe other methods.
It can do, yeah. With a press brake you need a really good high skilled operator that really knows what they're doing to get the best out of the machine.
And we'll talk about panel benders in a minute, but
yes.
Where is the market for a press brake compared to a panel bender?
A press brake is generally for a more universal application where a customer could be doing quite a diverse range of different bending applications, different product types, materials, things like that. They can get used in higher volume applications, of course, but you need quite often a lot of operators and a lot of machines to be able to do that.
Now let's look at the panel benders then, because some of the speed these things move, the flexibility of them, they really are a flagship product, aren't they?
Absolutely, yeah. The panel benders basically take over where the press brakes effectively stop, and that's the idea behind the panel bender, as you can see here, is that you can now take a piece of material, present it to the machine, and the machine will execute the bends. Depending on the complexity of the machine, because we offer various different models, the machine will either execute one series of bends on one edge.
We're creating a radius
Yes,
there.
absolutely.
And is that a true radius?
That's, yeah, because it's a stepped incremental radius, so you get a very, very clean form when you do that. The idea behind the panel bender is basically to take some of the onus away from having a really skilled operator, because he's just giving it the part. And depending on the level of complexity in the machine, either they'll have to turn the part and give it back to the machine, or literally give it the part and it will execute the series of bends and give him a finished bent product back again.
And what we're seeing here is, I mean, this unit that we've got in front of us here, this is the type of thing that would be made, isn't it? The drawers would be made on a machine like this.
Absolutely, prime candidate for it. So you've got a lot of repetition in there, a lot of consistency in what you're bending, and a high demand production volume. So this is perfect for a panel bender, where literally you're just giving it the same parts over and over and over again, and it will just keep making the same thing.
And how do the tools work? Do you change those? Do you change those in process, or how does that happen?
So basically what you've got on the tooling is you have a series of step tools running across the top of the machine for clamping the material, and then you have another set of tooling that comes in and executes the bends. Now, depending on the width of the clamps, depending on what the actual profile is that we're going to be holding, those tools can switch themselves around. So they're in, as you see there, they're in steps and segments. They will separate out to create gaps. They are different thicknesses so that you can create the best possible clamping zone so that you haven't got big open areas that aren't being clamped. They then support the material as the upper and lower tools then come in and actually execute the bend.
I mean, it strikes me again, I look at some of the applications and I think, God, in years gone by, it would have been such an arduous process, moving it around, doing the different bends. Can you then add into this other processes other than bending? I know I'm going a bit off kilter here, but we talk about flexible machines. What else can be done with them?
So basically what we actually do, I mean, this is a bending solution, so that's what it's designed to do. But generally speaking, with especially the more advanced automated machines, is we will complement these technologies with other processes that go then into a production line. So for example, a shearing or a punching technology, Other parts that have been done are then presented to the panel bender, whether they're in the same line or done offline, and then execute the bends in order to create the finished profile. So what you can actually do is create a series of parts that are all the same, or a kit of parts that go into making something like this. So we produce the drawers, we produce the outside profile, and then assemble everything together.
They look really fast, but sometimes I think to myself, if it is completely automated, the speed becomes a little bit irrelevant in a sense, doesn't it, sometimes?
Yeah.
Because if you're just continually making the components with no intervention, okay, you want to make them as fast as possible, but it's more important to get the part correct and accurate, isn't it?
Yeah. So the accuracy comes from the servo-electric control we've got in there. And again, when we're talking about a production line or an automated system, what you're looking for is a balanced load. So you've got a very consistent throughput that's predictable. And that's where, when we talk about the automation systems between perhaps the panel bender technology and, let's say, for example, one of our shearing machines, punch and shear machines, we then have the automation for picking the parts and bringing them to the panel bender, perhaps turning them over before they're presented, and balancing the load between the two of them so that the line itself is productive and predictable.
What is the maximum thickness you would bend on something like these?
That depends on the length of the part. It also depends on the material. They are designed more for thinner materials than thick materials. Obviously, with a thick material, you need a lot of bending force. And again, talking about what we're saying with the press brakes, that's generally speaking where the big hydraulic press brakes will come in. So you will generally find these on sort of 1, 2, 3 millimeters at the most. That's really where their application range falls, and exactly as you see in that part there, that's not a particularly thick part, but it's one that requires a lot of bending and would be complicated for an operator to do on a press brake, or perhaps too large.
It's evident to see the automation that is obviously key here to this process on these machines, but what about your service and support? What about if something like this goes wrong? What you know, you can't shut down an automotive industry,
No.
or you know, how do you maintain that relationship with your customers?
Prima Power are we were born into the automotive industry, and because we were born into the automotive industry basically means that we have to gear our service and support up around those demands. You don't stop an automotive production line. The costs for your end customer, and for any customer regardless of the industry, are too high. So generally speaking, our service and support is set up about giving that kind of a level of support to customers, fast reaction, having spares availability, having the technical support there that a customer needs, so that if something does go wrong, we're there straight away. On top of that, we offer complementary packages, whether it's just simple servicing or a full-on maintenance extended care package, so that a customer has got complete peace of mind, even once they're well out of warranty, that we will keep looking after the machine for them and keep their running costs as predictable as they possibly can be. Brilliant stuff,
brilliant stuff. So there you have it, bending technology from Prima Power. If you want to find out more, you can do that. We'll put the details on the screen below, and obviously you can contact Barry to find out more. Thank you very much, very informative, Barry.
Thank you.